Might even induce industries that have left Germany to come back home. Berlin's Kreuzberg district is home to a company called Big Rep, which makes large-scale 3D printers. Engineer Stefan Bayer founded the company in 2014. Now its 90 employees work in international teams to design and manufacture 3D printers for industrial clients.
Mit dem neuen Spruch drauf.
The printing is done with plastic, for example, to manufacture cladding for houses that regulates the inside temperature based on how high the sun is.
Das wird am Ende eine 10 x 20 Meter große Fassade.
This will be part of a facade that's 10 by 20 meters.
Im Sommer gehen die Strahlen.
The great thing about this cladding is that it reflects sunlight in summer and lets in sunlight during winter, which creates
ein angenehmes Klima.
Big Rep also makes spare parts.
Dieses hier, es handelt sich dabei.
This is a headrest for passenger train seats.
Für einen Zug. Stellen Sie sich vor, Sie kommen.
If the headrest is missing or broken, people are going to be uncomfortable.
Natürlich nicht. Und das ist
but we can supply a new frame.
Ein Ersatzteil, wo wir sowas verhindern können.
Big Rep has designed a headrest prototype and is testing it for German railway company Deutsche Bahn. The printer piles thin layers of material on top of each other, in this case melted plastic filaments. The process is known as additive manufacturing. It builds up objects instead of carving them out of a block. 3D printing is based on computer models. They could be scans of spare parts or entirely new products like this electric motorcycle. Here, the Big Rep team is building a prototype of the motorcycle that's to go on display 2 weeks later at the Formnext trade fair in Frankfurt.
We still have a lot of work to do before the Formnext. We have to get the printers ready and print out lots of parts.
Viele Teile drucken.
Almost all the bike's parts have come out of the printer, including the elastic tires, the frame, and the lights. Many components consist of biodegradable plastic made from cornstarch. The team needed just 12 weeks to get from the preliminary design sketches to the finished prototype. But they're still working out a few bugs. The engineers spent a year tinkering with the new printers, and now the machines can be installed in a production line and controlled automatically. That's an important step towards mass production. So far, 3D printing has been used mainly for one-off projects.
The great thing about 3D printing is that we can create parts that used to seem impossible. Classical manufacturing processes simply could not work with certain complex geometries, such as in furniture.
Or this gripping device for robots, which is based on the design of the human finger. The device is outfitted with flexible slats that provide a non-slip grip.
Die Faszination liegt einfach darin, dass
the fascinating thing is that our creative process is completely digital.
Das heißt,
engineers can sit down at the computer and just design something, and their imagination is no longer limited by classical production methods such as sawing or milling.
Wie zum Beispiel Sägen oder Fräsen.
This revolutionary new concept may well improve the ways that industry designs, manufactures, and transports its products. Chicago is home to a number of new high-tech companies, including Fast Radius. They print components that are precise and durable enough for use in the mechanical engineering industry. Fast Radius often uses plastic resins, which allow for faster printing. The process looks like something out of a science fiction film. The metal foot dips into the resin solution. The components solidify on the bottom as if by magic. No molds are needed. Light sources inside the solution ensure that only certain parts harden and take shape. This process makes the product lighter and also uses fewer raw materials. The company's co-founder and CEO is Lou Rassi. Fast Radius is working with logistics company UPS to completely rethink the concept of supply chains.
Additive manufacturing will have a profound impact on how global supply chains work. We call it the fourth modality of logistics, in fact. What we mean is that through human history, we have moved parts in three ways: by ground, by air, and by sea. And now we have a fourth mode of transportation, and that is moving parts by the internet at the speed of light.
Digital production offers a tremendous freedom to potential clients. A global 3D printing network can provide products more efficiently. Transport routes are shorter, and there are no huge specialized factories. These days, 3D printers can make just about anything, and robots automatically supervise the assembly lines. These machines can print single pieces or entire series of products, 24 hours a day. But so far, 3D printing accounts for only a small percentage of global manufacturing sales, which now total about $12 trillion. Revenues for the 3D printing industry in 2017 were only about $7 billion. But over the next 10 years, sales are expected to reach $100 billion. A lot of spare parts are now made by 3D printers. Companies can simply scan and store the components instead of keeping them for years in warehouses, and they can print new parts whenever they need them.
Move it into a specific position, take this information.
How many data points do we get for this part?
From each scan, it's in the millions of points that we're gathering. And now for a part like this, millions of points is a little redundant. So what happens is the computer itself notices redundancies, points where it can simplify, and then throws away hundreds of thousands of points.
The scans are stored in a digital facility and can be printed at any time. The companies save money because they don't have to keep lots of products in big warehouses. And their machines last longer because spare parts are always available.
One of our clients is an aerospace client. They had a need for a critical tool for repair. Normally it would have taken them 48 days to have the tool fabricated in conventional methods. Instead, they ordered a part from our virtual warehouse, and we made the part, certified the part, and delivered it halfway around the world within 48 hours.
It's often faster to print a component part than it is to build it from scratch. In future, this will likely be done on site. This situation threatens to transform the way that logistics companies like UPS do business. It would eliminate lengthy transport routes or warehouses for customers' spare parts. That's why UPS has teamed up with Fast Radius to start building a global network of 3D print service providers.
It allows goods to be produced in lower quantities, more often, closer to the point of consumption. That's going to radically change the supply chain, and UPS has to be able to change with it. And so that's why we're investing in this area, because we want to be part of this evolving ecosystem.
Many products will no longer be mass-produced. They'll be printed individually to meet the specific needs of clients. That will help to eliminate overproduction and long transport routes. 3D production also offers a number of other advantages.
If you're producing for an audience of one, so a custom shoe or a custom knee or a custom orthotic, those are not going to be produced in massive factories. It's going to be much more economical to produce those using 3D printing. And so, but all of those materials still need to get to the 3D manufacturer. And instead of, shipping out, thousands of things in bulk, you're going to have thousands of individual shipments. So to a company like UPS, that's very good.
It might be good for UPS, but less so for traffic and the environment. It means more trucks, delivering more products and emitting more pollution, an effect we've already seen with the rise of online shopping. And there are other risks. For example, how can 3D printing companies prevent the manufacture of illegal weapons?
What we're doing, we make sure we screen every company that we're making parts for to ensure that they're not making unregulated firearms.
Yeah, vigilance is really the key.
But criminals will always find ways to get the weapons they want. Homemade firearms are nothing new. But today's high-quality 3D printing materials can withstand extreme pressure and heat, so they could be used to make weapons. In 2013, some Israeli reporters used a 3D printer to make a handgun and then tested it.
Just about a headshot.
Later, the reporters smuggled the gun into the Israeli Parliament building in Jerusalem. The gun had a metal firing pin, but security devices failed to detect it. Israeli Prime Minister Benjamin Netanyahu was attending a ceremony in the building. The reporter who had the 3D gun was seated just 10 rows away from him and even pointed the weapon at the Prime Minister. Netanyahu's office later criticized the reporter's actions as irresponsible. The Hamburg district of Finkenwerder is home to an Airbus factory. The head of the company's emerging technologies department is Michael Zillus. His team uses 3D printed prototypes to help improve components.
Additive manufacturing definitely has the potential to change the entire value chain. We can do production on site, redesign processes, and print on demand. We can develop completely new products for next-generation aircraft.
This is where Airbus assembles its A350 passenger jets. A key component is now being printed in quantity, the door-locking shaft. They're due to fly in the aircraft later this year.
This component usually consists of 10 parts, but the Airbus version has just one. We've integrated several functions and reduced the weight. There are 2 of these parts per door, and they make the aircraft lighter by 4 kilograms. That's a lot in the aviation world. It cuts down on fuel consumption and CO2 emissions.
Over the 30-year lifespan of an aircraft, 1 less kilogram of weight will save 500,000 litres of fuel. The A350 actually has a lot of 3D printed parts. 16 door-lock shafts, 20 brackets for the crew cabin compartments, and more than 1,000 plastic parts in panels, ventilation systems, and electronics gear. Airbus is even testing prototypes of electrical parts. 3D printing is typically used to build grid structures like this cabin partition wall. The printed version uses less material and so is lighter than previous models. Airlines are always trying to reduce the weight of their planes to save fuel, but Airbus believes the 3D process could be even more efficient.
This is the largest component that we can make right now. We'd like to build bigger ones. It took us a total of 900 hours to produce a complete partition wall and 7 construction chambers. That means we had to start up a printer 7 times to produce the 116 parts we needed.
900 hours of printing time for just one wall. That's a lot of work. In future, the hope is to print a mold and then cast it again and again. Right now, conventional mass production methods can still produce components like this more quickly and cheaply than 3D can. But that could soon change. This is the Formnext Additive Manufacturing Trade Fair in Frankfurt. There are some sophisticated examples of 3D technology here, like this model of a human body, printed in one go. Klaus Emmelmann advises companies on which 3D production methods might work best for them. He says that more and more businesses are making the transition to this technology.
The automotive industry is now starting to design 3D components for their vehicles. That's good for the environment, because those parts will be produced only on demand. And they can be made using powder, which can be delivered locally, and printed out anywhere in the world where they're needed.
For example, these lightweight brake pedals were made by 3D printers and produced at a local factory. That cuts down on waste and emissions.
We typically save 6 tons of CO2 emissions per kilo compared to conventional methods.
This facility in the state of Lower Saxony will be able to print 3D component parts out of aluminium fully automatically. This technology could encourage companies to keep their production facilities in Germany instead of exporting them overseas.
We can bring those factories back to Germany, provided that they're fully automated. And if we can do that, we'll increase the economic value of German companies.
But traditional mass production is still unbeatably cheap, particularly in Asia. 3D printing will have to bring something else to the table, like printing several components at once. Such innovations could enhance the competitive profile of German companies. 3D printing is already well known for its ability to produce complex prototypes. The motorcycle designed and built by Big Rep was finished in time for the expo, but company executives say that they'll have to do a better job of giving customers what they want.
We all know that for 30 years, think about it, 30 years there's been a promise made to the industrial customer out there what 3D printing can do for them. We were talking about speed. Are we fast enough in printing? We're talking about precision. Is that what's coming out of the machine really what we want? Is it repeatable? Are we getting the same part over and over again? This is what the customer, the industrial customer wants, and I think we all agree there has been great disappointment around it. Then that we're going to change today.
For some applications, many kinds of 3D printing are still too slow, too imprecise and too expensive, but improvements are underway. The new Big Rep printers work up to 10 times faster than the old ones. Printing speed is the key to making 3D technology more profitable. And carbon fiber materials can make the printouts more durable. In fact, a US firm called Carbon, based near San Francisco, has teamed up with Additive to make soles for sports shoes. Additive is a pioneer in the use of 3D technology in its products. The co-founder and chairman of Carbon's board, Joseph DeSimone, invented a process that allows for the mass production of custom-made 3D components. His company's partnership with Additive is a big step forward.
No one's ever taken 3D printing to high volume. Additive represents a seminal moment, I would argue, in the history of industry, where we've got volumes that now allow us to have a cost-down curve, just like injection molding.
This process could present a cost-effective alternative to conventional mass production methods. 2 years ago, it took more than 2 hours to print a shoe sole like this one. Now it takes just 30 minutes.
This will allow the 3D printing world to go from a $10 billion prototyping world to a $300 billion manufacturing juggernaut.
So far, that's just a vision. The grid structure of the 3D shoe sole cannot yet be fully customized. And production will not be relocated to Germany, where Additive is based. The printed soles are shipped to factories in Asia, where the shoes are assembled. So right now, this is not a particularly sustainable production model, but that could change in future.
Did digital sustainability. That's a combination of things. One is dematerialization. The other one is mitigating supply chains, right, and having parts on demand or local for local production. But it goes well beyond that. We've had some breakthroughs now where we can get into bio-based feedstocks.
Carbon still mainly prints with polymer resins that are petroleum sourced. The light-sensitive materials enable the company to make products with complex grid structures that are more lightweight. But it's also working on ways to make the products more sustainable.
Adidas is going to do an all-polyurethane shoe. They've set targets out in the next 10 years or less to have shoes that are recyclable. And we have the ability of doing that.
Here at the Frankfurt Trade Fair, such visions of sustainable 3D printing sound like a welcome development. But how likely are they to be realized? Economist Ulrich Petschow is skeptical about promises from the industry.
These are mainly visions or hopes for the future. At this point, there's not much evidence that more sustainability is really being achieved.
Petschow works at the Institute for Ecological Economic Research in Berlin. The institute has done a study on whether a mobile phone case printed at home in Germany is more environmentally friendly than one that's mass-produced in Asia, and found out that they're about the same. That's because the lower CO2 emissions from local 3D printing are offset by the higher energy consumption of the printing machines.
This process is neither particularly sustainable nor economical, but it can be profitable for some companies under certain conditions.
Companies can generally make money on expensive 3D printing projects only if they can speed up or streamline production. Still, they'll use fewer materials, and some products could be recycled, even if they're custom-made. We've come to the Reflow Recycling Company in Amsterdam to find out whether 3D printing production really is sustainable. About 80% of printed products are made of plastic, and only a fraction of them are recyclable or biodegradable. This machine at Reflow turns discarded plastic bottles into plastic filaments that can be used for printing. The granules come from PET bottles. The material is suitable for 3D printing, and it's cheap. Filaments from Reflow were used to build the walls of a shop in London that sells fashions made from recyclable materials. Sustainability is often good for business, but not everyone is willing to pay more for these products. So Reflow sells its recycled filaments at the same price as its competitors, whose products are less sustainable.
A lot more attached to their product. Instead of something, that industry is interested in sustainability because basically their consumers are asking for it, right? It's a big macroeconomic trend, and industrial players will just have to follow.
For example, Reflow supplies 3D materials to a company that makes sunglasses. This would replace an entire block of raw plastic from which the frames are normally milled, and that cuts down on plastic waste. Reflow's recycling technology is already being used in several other countries. In India, plastic bottles picked up from garbage dumps can be converted into plastic filaments for 3D printing, and those who collect the bottles can earn some extra income. This technology can help to enhance local value-added cycles all over the world, converting discarded plastic into useful products. The 3D printing industry